Look what we have here. The Sovol enclosure for the SV08 has just arrived, and I must say it looks stunning. These small glass doors and top panels give the printer an elegant appearance. The powder-coated aluminum side panels have a good fit both physically and aesthetically. But will they keep the heat inside? And the noise? How does it limit the vertical movement of the tool head? I'll show you with and without this top hat razor. Does it really improve ABS printing? How about PETG? And will PLA still print okay? How involved is the installation? I've encountered some trouble during the assembly. Overall, is this upgrade worth the price? In this week's video, we'll address all these questions about the official enclosure from Sovol. I'm Gergo, and you're watching Gergo Print 3D, the YouTube channel dedicated to my 3D printing adventures and DIY projects. This isn't my first video on the Sovol SV08. I've covered a series of topics related to my Sovol printers and even some other DIY tools and techniques. Feel free to look around. If you need them, subtitles are available. As always, I've put a lot of effort into them. With this out of the way, let's see what we get in the box. It weighs 8.57 kilograms according to the shipping label, which is important information since this minus the weight of the packaging is going to be added to the weight of the printer. I later found the empty box and packaging to be exactly 2 kilograms, so the added weight to the printer is 6.5 kilos. Even more important, of course, is what's inside. At the very top, we find the hefty 20-page installation guide. I paused the video here and spent some time familiarizing myself with it. You'll soon see to limited benefit. The front half of the top panel is made of thick, heat-resistant tinted glass. The handle on it is pre-installed and seems to be 3D printed. The glass components are cushioned with thick foam, and here we have the back half of the top panel. In the next compartment, we find a 22-segment cable chain and 4 strips of self-adhesive foam tape, which, although not listed in the booklet, I've used to cushion the edges of the glass top panels. There's also a bag of smaller accessories. We'll delve into those shortly. Included is a 24-volt 80-25 chamber fan, the bottom cover part of the cable chain, 3D printed from what I hope is high temperature resistant filament, similar to the top part that attaches to the gantry. You'll hear much more about these soon. Lastly, there's the dust filter for the chamber fan, which we'll examine more closely later. At the next level, we find the glass front doors, which come with handles, top and bottom magnets, and the top hinges already installed. I later measured them to be 3 millimeters thick. They warn us to keep the doors open when printing PLA. More on this in my tests. We've arrived at the side panels. This one is designed for the right side, as you can tell by the cutout for the filament feeder on its top center. Additionally, the 2 black tapes are there to safeguard the camera cables at the front and back of the moving gantry, preventing any damage. Then we see the left side. This has no tape or cutouts. Finally, we have the back panel, distinguished by the chamber fan grills and a strategically placed hole for the fan cable. Okay, this is all we get in the box. I measure the thickness of the powder-coated aluminum panels to be 1.5 millimeter. Let's take a closer look at the smaller accessories. We get screws sorted by size in little bags labeled with steps 1 through 5, which, as is typical with Sovol, do not correspond to any steps in the user guide. These two are the top and bottom door stops. The magnets on the corners of the doors will snap onto these. Then we have the left and right fixed parts of the hinges, which I of course mixed up. The other two I confused are these left and right hinges. Finally, we get a new set of tools for some reason. Yes, a lot of bits and pieces, but what does it take to put them all together, as you can see here? As usual, I read the installation guide booklet first and set out to follow the steps in order. But this time, there were some detours and dead ends. Trust me, I made all the mistakes, so you don't have to. I brought the printer out of the small studio room. You'll be better off if you can walk around it with unhindered access from all sides. The first steps in the booklet instruct us to install the included cable chain. In step 1, we are to remove the so-called wiring harness bracket, the one that attaches the umbilical cable to the gantry with a single screw. Easy. I quickly realized that the gantry needed to be raised for better access. I turned the printer on, homed it, and moved Z to 250 millimeters. After turning the printer off, now I was able to pry the cover open with a flathead screwdriver. We get replacements for both the top and bottom pieces that can attach to the cable chain. The next two steps will have us do just that. We'll need 3 of these M36 screws to fasten the top end of the cable chain to the replacement bracket. Watch out for the direction. Of course, I screwed it on the wrong side first. This is how it should go. And here, at step 3, we arrive at the main pain point of the assembly. I spent the next hour or more on this. Perhaps the original harness bracket was meant to fit into the new one, but it didn't. So I removed it from the cable. However, this was just the beginning. The more significant issue arose when I realized that if I fastened the new bracket to the original mounting point on the gantry, the AB motor cables would not be long enough to reach the motors. I think my batch of units came with a slightly shorter umbilical cable than the cable chain was designed for. I even flipped the printer over to see if I could loosen the cable, but without success. Having the bottom cover open, I used the opportunity to skip ahead several steps to route the chamber fan cable. 2 full pages in the user guide are dedicated to this. The fan comes with an extension cable section. I managed to route this extension from the header marked fan 2 on the main board to the hole on the base of the printer where the replacement wiring cover will go. It's good to have that prepared, but let's return to the main task at hand. The ultimate solution in my case was to drill a new hole in the gantry, closer to the back right motor. When fastened to this new point on the gantry, we still have enough cable for the tool head to reach the furthest point on the build surface at the front left. I guess we can call this a success, though way too hacky, even for me. I wouldn't blame you if you skipped adding the cable chain. At least we are back on track, continuing with the installation of the fan onto the back panel. Smooth sailing from here. The fan goes on the outside, of course. I recommend orienting its wire toward the bottom of the panel, aligning it with the hole that leads to the extension cable we've just installed. Use the 4 M4x35 screws to secure the fan to the panel. ensuring that the X-shaped motor mount faces outward to direct the airflow correctly. The air filter is essentially a thin piece of foam designed to capture some of the harmful microparticles that are released into the air during the printing of ABS and similar filaments. I've noticed that the fan is set to run at 100% in the ABS filament profiles, whereas it remains off for PLA, PETG and TPU. Despite this, I would still advise against staying in the same room as the printer while printing ABS. Ensure the room is well ventilated and wear an additional protective mask when entering. Once the air filter is attached to the fan, it's a good time to route the fan's power cable through the hole. Then we are ready to mount the panel on the back of the printer using 9 M3x8 screws. You'll notice that 2 of the corners have insets. These should be positioned at the bottom. After this would be the best time to connect the fan cable to the extension on the inside. I forgot, and it was a bit more difficult later when the side panels were already installed. Yes, I got a little carried away and installed the side panels too. The one with the cutout for the filament feeder and black tape on the inside should be placed on the right side, which is correct. However, the booklet advises adding these at the very end. Having them on earlier made the rest of the assembly process much more challenging. Don't be like me. Now we are on page 12, installing the glass doors. This step involves several components, so let's go through it systematically. We start by installing the door stops. We place them in the center of the front panel, with one at the top just below the Sovol logo and the other at the bottom above the mini screen. Next, we install the fixed part of the upper hinges. Make sure not to mix up the sides. I did. The countersunk M3x6 screws should be fastened from the inside if done correctly. Now we place the rotating hinges at the bottom. Ensure the protruding part points toward the front of the printer. Otherwise, you won't be able to open the doors. Don't ask me how I know this. With the hinges in place, we can now mount the doors. We start by matching the upper corner of the door with the upper hinge. Then we use 2 M3x8 screws to fasten the bottom corners to the bottom hinges. It's very important to add the little plastic studs so that metal never touches glass directly. When fastening these screws, I recommend lifting the door up slightly to ensure the bottom edge doesn't rub against the frame, which will allow the door to open much more smoothly. Repeat the same process for the other door. Watch out, don't over-tighten the screws that go through glass. If you're using an electric screwdriver like I did, set the torque to a low value, 1 or 2. At least I did not make a mistake on this. Beautiful. The magnets on the doors are very strong. If one falls out, use some super glue to adhere it back into the slot on the door. Again, I know this from my own experience. The final step of the installation is to add the glass top panels. The shorter piece goes in the back, while the larger one goes in the front. No fastening is necessary. Their weight will hold them in place on the top. The concept is that we can lift the back of the front piece and slide it on top of the back piece to have the front half open. But you'll see, when we open the top, we will want it fully open. We'll remove both panels before printing PLA, you'll see. The whole assembly took more than 2 hours for me. That includes all the mistakes you won't need to make, and also all the camera work that is substantial and you won't need to do those either. But the end result is nice, of course. What do you think? Was I too clumsy, or is the installation of an enclosure supposed to take this much effort? At least half the assembly time I've spent on the cable chain. I'd say you'll do fine without it if you want to skip it. With everything assembled, it's time to put things to the test. Let's start with the obvious. Will the existing functionality work as before? I noticed a strange problem initially. The camera picture flashes. No, it's not a connection issue. After some experimentation, I realized that the side panels and the lighting in my room were interfering with the camera backlight compensation. The solution is easy. I added this line to the configuration, V412 CTL colon backlight underscore compensation equals 0. And that resolved the issue. How about the movement of the tool head? We can expect limitations in the Z direction, but how much? With the glass top in place, I was able to drive the extruder to 320 millimeters, which is 27 millimeters less than the original limit of 347. However, the cables were already touching and dragging on the new roof of the printer. A more realistic limit would probably be around 300 millimeters. Of course, everything changes if we add a top razor. In fact, I had the link to the STLs even before receiving the enclosure. I'll post the links in the description of this video. See? It is cut into 4 pieces to fit the build surface of the Sovol SV08. I decided to print them out of PETG, hoping they'll withstand the elevated temperatures. I'm already using Sovol's new filament presets, which will require some start macro modifications for proper functionality. I know I've been promising a video about these modifications for a while. They are imminent now. Be sure to subscribe not to miss them. Other than that, this is an easy print. I set 3 walls and minimal infill. The bottom edge requires support. I enabled the normal type of support, which will only fit if we also set its style to snug. PETG tends to fuse with supports excessively, but setting a 0.3 mm top Z distance made removing them effortless. I actually printed 2 of the parts before the enclosure arrived and 2 after, so we can compare the print quality of PETG with and without the enclosure. And they are indistinguishable. PETG prints well when fully enclosed, and an added benefit is the reduced noise levels. We'll measure them in a minute. The parts snap together like puzzle pieces, and the necessary 12 M3x8 screws were included with the enclosure. The glass panels fit as before, raising the height of the printer by 51 millimeters. At 635 millimeters, the printer will be taller with the razor, of course, but it won't change the overall space requirement since the spool holder is still attached to the original top frame. Notice that it has many holes, which is intentional. Sovol's website describes the enclosure as an open style enclosure. No insulation on the panels. In fact, the doors have a 1.7 millimeter gap between the closed wings. We can also find the mounting points for the official touchscreen on the right side of this razor. The idea is to keep the mini screen at the bottom and install the touchscreen on the top. I'm exploring various touchscreen options and I'll create a video about them also soon. Even if I hadn't conducted this test, you could already calculate that the added height of 51 millimeters eliminates any Z height limitations. allowing the gantry to reach the original 347 millimeters maximum. To print the complete hat, you will need about 700 grams of filament, increasing the added weight to 7.2 kilograms, which is expected to have an effect on the input shaper resonance test. What would be your guess? Positive or negative effect? Overall, I found a very slight negative effect on both X and Y acceleration limits. You can pause here to analyze the graphs more deeply. Good? So, no significant drawbacks. But are there any advantages of enclosing an SV08? Besides dust protection, the first benefit that comes to mind is noise reduction, right? I tested it 1 meter away from the printer with open doors, measuring a peak level of about 70 decibels. With the doors and top closed, that dropped to 60 decibels. That's a significant improvement. I can barely hear the enclosed printer from the next room. Heated chamber as a benefit? Well, there is no dedicated chamber heating. We rely on the heat generated by the bed to be more or less retained inside. But what temperatures can we expect? I conducted a test. I heated the bed to 95 C, the recommended temperature in Sovol's ABS preset, and monitored it for an hour. Unfortunately, there is no direct way to measure the chamber temperature. Please correct me in the comments if I'm mistaken. Since the nozzle isn't heated, I used its thermistor reading 50 millimeters away from the bed surface. I also placed 2 cheap digital thermometers inside and recorded this hour-long video. The results settled between 40 and 50 Celsius. With my limited knowledge, I'd say this is ideal for printing ABS or ASA, but we'll need to heat soak the chamber for at least 30-40 minutes before printing. To put this to the test, I printed a dice tower out of ABS without the enclosure, fully expecting warping and layer separation issues. I had problems with this model on my old printer. However, to my surprise, there were none here. I even got more complacent and printed the trays on the unofficial smoother side of the PEI sheet. No warping or adhesion issues there either. So, the SV08 can print ABS fine without the enclosure. I repeated the test with the side panels installed, doors and top closed. I noticed 2 benefits. The printer is much quieter this way, and ABS is much less pungent. Sovol's ABS presets activate the chamber fan when printing ABS, and the filter seems effective. While I still open the windows and avoid staying in the room during ABS prints, the noise and potential health risks are slightly reduced. And I'm confident that larger parts, more prone to warping, would also print much better. What did we miss? Oh yeah, PLA. I printed the reference model without the panels, then tested printing with the same settings in the enclosure, but as the notice suggests, with the front doors and top open. The result is disappointing. We can clearly see cooling issues. The enclosure has a negative effect on PLA printing. Of course, I couldn't leave it at that. I did a second test, increasing the cooling by 20% in the PLA preset and removing both top panels, not just the front. The new result is more encouraging. We get an almost identical print to the first one without the enclosure. Well, that was a lot of tests. Are you ready for my opinion? This being my first enclosed printer, I cannot give you a proper review, especially not after just 2 days. But here are my first impressions. Man, it looks beautiful. I've always liked the look of the SV08, but this takes it to the next level. The printer now feels complete. All parts fit together beautifully. The tinted glass doors feel premium. The hinges work smoothly, especially if you don't mix up the sides. And the magnets hold well, though you might need some super glue at hand, as we could see. The glass top, again, looks premium. Though the opening mechanism might need some improvement, maybe I'll redesign this top hat with raised edges to guide the sliding half. The aluminum side panels make a bit less sense to me. Their thermal conductivity doesn't really help keep the heat inside. But at least they don't hinder the movement of the gantry. Initially, I was concerned about the camera cables touching the sides, but they are well designed and out of the way. The location of the chamber fan is not the most convenient for my placement of the printer back in the printer room. With my printers back to the wall, I would have liked it on one of the sides instead. Maybe I can move it, though poking holes on these beautiful side panels would feel bad. And clearance would need to be solved inside for the gantry moving so close to the walls. But I liked how well the fan wiring was thought out. And yes, the cable chain, it did not work out of the box. Maybe it will on production units, but it is not strictly necessary in my opinion, just a nice addition if you want to invest the time to assemble it. Besides the look, the enclosure gets the job done. It aids the printing of sensitive materials like ABS and lets us vent the poisonous fumes to the outside. With the doors and top open, it doesn't seem to hinder cooling PLA. We could just raise the cooling fan speeds a bit in our PLA presets. When it comes to PETG, having the doors closed will make the printer significantly quieter. So, is it worth the price, time and effort? What we always say, it's ultimately up to you. You can probably get away with any makeshift side panels, as the screw holes are there for easy installation. Depending on the material, they might even be better at keeping the heat inside. But it will not look as premium as this. I guess it also depends on where you keep your printer. If it's in your office or studio, you might be more conscious of the look besides the functionality. So, I did my best to answer all the questions you asked before this video, but keep them coming. I respond to every comment as I do for all my videos. By the way, please use my affiliate links in the description. They help support the channel at no extra cost to you. Be sure to subscribe because there is a lot more to come. I'm getting various touchscreen options and I'm still waiting for those nozzle kits. And the next video will be on those long-promised Orca filament presets and macro improvements. Until then, my Orca filament tuning video is a must-see, and feel free to look around in the growing collection of other videos about my printers. But first and foremost, go print 3D. Thank you for supporting Gergo Print 3D.